This is question 9, test 5, section 8, and I find that students have difficulty with it. I'm just going to explain a couple ways you could solve it. Okay, so this question reads, a regulation for riding a certain amusement park ride requires that a child be between 30 inches and 50 inches tall. Which of the following inequalities can be used to determine whether or not a child's height h satisfies regulation for this ride? Okay, so one strategy and one of the easier strategies is to use the inequalities, the answers that they've given you, and find out how they break down when you set what's inside the absolute value symbols equal to the positive and negative answer choice. Since you know that these absolute value symbols convert what's inside them to a positive answer. Okay, so let's do that for the first one. H minus 10 equals 50. So that means, oh, I'm sorry, I'm going to reproduce the inequality symbol is less than. So then that means H is less than 60. And then if we set it equal to the negative of 50, then we get H is less than negative 40. So this does not accurately capture the span that we're looking for, which is between 30 and 50, because this is between, well, it's actually, yeah, it'd be between negative 40 and 60, because this, sorry, this should be flipped. Okay, let's test out another one. I'm gonna jump to D to show you what that will look like. Okay. So we got rid of A. Okay, so D is H minus 40 is less than 10. And when we add 40, we get H is less than 50, which is good because that's what our original equation was telling us. And then let's see what happens when we set this up with the negative version. Okay, so then we get H is greater than 30, which this is exactly what we want. So I do want to make a note that in the first example that I did, I forgot that when you're setting it equal to the negative answer, you need to flip the inequality sign. So you flip the inequality sign and set the information in the absolute value symbols as the opposite sign, opposite inequality, and the negative version of the number. Okay, so D is the right answer, but let's just go through and see what happens with B, C, and E, just so you could see how you would implement this strategy. Okay. So you'd have H minus 20 is less than 40, and you add 20. So automatically we know this is out because we have H is less than 60, and we know that the numbers between 50 and 60 are not okay for the height of the child. Now, just to give you more practice with flipping that inequality sign and changing the number to a negative, I'm just going to show you the other option for B. So it would be H minus 20 is greater than negative 40. And this once again is not okay because those numbers between 20 and 30 are not adequate heights for this ride. I see this to be negative 20 actually. Okay. So that's even, if somebody's negative 20 inches, that's a problem. Okay. So B is out. And let's just carry this out with C as well. H minus 30 is less than 20. So this part of it is fine. H is less than 50, but the other part of it won't work. So let's carry out that part of it. Okay, so we're plugging in H minus 30, we're flipping the inequality sign to greater than, and we're changing the charge from positive to negative. And so this is where we'll run into a problem. So h is greater than 10, which is not true because we know that the heights between 10 and 30 are not sufficient for this ride. And then lastly with E, h minus 45 is less than 5 plus 45. So this first part works, but the second part won't. H is less than 50 is great. That's what we want. But let's see what happens when we flip the inequality and make the 5 negative. So then we get h minus 45 is greater than negative 5. And then this is where we'll run into a problem. So we get h is greater than 40. So this span is just too short because it doesn't include the heights between 30 and 40 that are sufficient for the ride. So if you picked E, you did a lot of good investigative work, but E doesn't work. It works for a lot of the options that work, but it doesn't cover all of the heights that can fit this description of being between 30 inches and 50 inches tall. Okay, I'm going to stop the video here, and then I'm going to explain another way to do this problem in the next video.